Assalamualaikum warahmatullahi taala wabarakatuh and guten tag. My name is Muhammad Azhin bin Muhammad Hatta. Currently, I'm furthering my studies in Bachelor of Electrical Engineering at UiTM Shah Selangor. On my 7th semester, which is my current semester, I have a subject called Engineering in Society or EIS. I'm a class of EE 2427B. Our lecturer, Dr. Fahmi, gave an assignment to us to make a video about all the topics that have in our subject. For our group to K to B, the topic was the first chapter, which is Introduction of Engineer Profession. Me was assigned to make a video about do's and don'ts of engineer. There is many acts that engineer must obey under this topic. I'm gonna present to you about this subtopic by using the Prezi application. Prezi application was really helpful on doing my presentation because it was really smart. Without further ado, let's proceed to my video. Hello, welcome back. Here's are the Prezi application that I mentioned before. Okay, let's proceed with the title first. Do's and Don'ts of Engineer, Code of Ethics of Board of Engineering Malaysia. Let's proceed with the registration columns first. Okay, under Registration of Engineer Act 1967, there is a few regulations that you have to obey. Let's proceed with the do's thing. Graduated engineering student in Bachelor of Engineer must register with the Board of Engineer. In Malaysia, we call it as Lembaga Jurutera Malaysia. Once you have graduated in any field of engineering, you must sign up for Board of Engineer at Lembaga Jurutera Malaysia. That's the do's thing after you graduated. Okay, now we are proceed to the don'ts do thing. Under this act, there is 4 don't do things. First is engineering drawing. Let's have a look. Don't ask a person to design engineering drawing if they're not competent. Yeah, if someone doesn't have any competencies on their field for the drawing, you should not ask them to draw for the mechanical or electrical drawing. This will cause a problem later on. So, you must not hire someone that not competent. Next is don't sign or stamp. Don't sign or stamp on a report or plans that they're not created. If you are not sure with the plan or the report come from what source, you must not sign it, because if you sign any report or plans, it means you is under your responsibility your sign. Okay, the third one is political parties. Do not engage or doing a partnership with any party that not permitted. As you all know, there is a lot of parties in Malaysia. Many of them are not permitted, so you should be aware of it. Let's proceed with the last part, which is the engineering service. Don't provide engineering service if not competent. Let's have a look with the picture below. It looks like a distraction on the highway. This picture shows how incompetencies of the engineer on designing the roads. So, make sure you do not provide an engineering service if you are not competent. Okay, we have settled with don'ts and do's thing under the Registration Act 1967. Right now, we want to proceed with the engineer nightmare. Everyone or every job have a nightmare. For the engineer nightmare, I'm showing you 6 construction failure around the world. Let's proceed.
Scientists sometimes get a little excited when an experiment doesn't work the way they expect it to. It's an opportunity to learn something new about the world, and they can always change the experiment a bit to try again the next time. Engineering is a little bit different. Designers and engineers generally prefer to find out something's wrong before it's built instead of after, because engineering failures can be disastrous. But engineering failures have happened, and if nothing else, they're an opportunity to learn what not to do next time. When it opened in 1878, Scotland's 3.2-kilometer Tay Bridge was the longest bridge in the world. It was so impressive that Queen Victoria knighted Thomas Booch, the bridge's designer, after she took the train across it. But on December 28, 1879, a train was crossing the Tay Bridge during a violent storm when the middle of the bridge collapsed. The bridge, the train, and the 60 or so people on board crashed into the water below. There were no survivors. An official investigation found so many problems with the bridge's construction and design that they couldn't even figure out what failed first. But according to their report, Booch did just about everything wrong. They tested a lot of the bridge's surviving components, for example, and found that they couldn't stand anywhere near the pressure they were supposed to. So the bridge would have failed eventually anyway, and the storm just accelerated things. And when investigators looked at the columns that had been holding the bridge up, they saw that they were broken at the bottom, so the columns might have been responsible for the bridge's collapse. The winds could have made the train rock as it went along, maybe even forcing it against the bridge's walls. If that had happened, it would have put a lot of extra stress on those columns, breaking them and bringing the bridge down. Whatever the reason the Tay Bridge fell, engineers found even more problems when they looked at some of Booch's other projects. Some of their components were either just as badly made as the ones on the Tay Bridge, or they were arranged in ways that meant they couldn't hold much weight. Apparently, he just wasn't a very good engineer. The Tay Bridge disaster made it clear that those projects were also ticking time bombs, and that bridge inspections had to be way more thorough to stop these kinds of things from happening. The other bridges were either quickly repaired or destroyed to prevent another disaster. But the Tay Bridge, of course, was not the last bridge to collapse. The Quebec Bridge was set to become the longest cantilever bridge in the world when construction began in 1900, but it collapsed twice before it eventually claimed the title in 1917. Cantilever bridges are made of big, bulky parts that support relatively flat sections between them. And during construction, workers kept noticing that some of the support pieces were bent more than they should have been. They were holding way more weight than they were designed to, partly because the bridge ended up longer than it was originally planned to be, but to save time and money, extra support wasn't added. The designers hoped that the problem could be fixed as construction went on, but at the end of the workday on August 29, 1907, parts of the bridge collapsed under their own weight, killing 75 workers. Construction resumed after investigators figured out what happened. Their main conclusion was that the bridge's components just weren't strong enough. So the bridge was rebuilt, this time much bigger and stronger. But all that extra metal made it much heavier too. And as the middle section was hoisted into place in 1916, the equipment bringing it up broke and it plunged into the river below. This time, 13 people died. The Quebec Bridge disaster was a reminder that it's important to make sure that the thing you're building can carry the weight you're putting on it, and it probably would not have happened today. Over the last century, engineers have developed tons of new mathematical techniques and computer programs that probably would have caught the first collapse long before the bridge was even built. Even before it opened in 1940, people noticed something strange about Washington State's Tacoma Narrows Bridge. It moved. Gentle winds could make the long suspension bridge flex up and down by meters at a time, making it hard to drive or even walk across. The bridge's designers tried to keep it from bouncing so much by installing shock absorbers, but they weren't very effective. And then, about 4 months after it opened to the public, one of its cables snapped from how high the bridge was bouncing in a strong wind, and the other cables started to slide around. This let the bridge start twisting back and forth instead of bouncing, and eventually the middle broke off and fell into the water below. Unlike the Tay and Quebec Bridge disasters, there was only one fatality this time, a dog named Tubby. Tacoma Narrows failed because of of something called aeroelastic flutter. When that first cable snapped, its side of the bridge fell slightly because it was less supported. Then other cables on that side pulled up like stretched out rubber bands, and the bridge started twisting back and forth. Then the wind gave each twist a little boost. Those small boosts built up over the course of the morning and eventually twisted the bridge apart. Engineers learned their lesson pretty quickly and reinforced the Bronx Whitestone Bridge in New York, which was also known to flex in the wind. And that bridge is still standing today. But not all failed construction projects have been bridges, though. The 40-story Hyatt Regency Hotel opened in Kansas City, Missouri in 1980, and it quickly became known for its innovative atrium, which featured 3 long walkways that seemed to float in the air. The hotel called them skywalks. Instead of being supported by pillars, each skywalk was suspended from long rods hanging down from the ceiling. The second-floor skywalk hung below the fourth-floor skywalk, with the third-floor skywalk off to the side on separate supports. Their unique design made the huge atrium an ideal place to host events and parties, like the one that the hotel hosted on July 17, 1981. About 1,600 people attended. Hundreds danced and talked in the atrium, while others milled around the hotel and checked out the famous skywalks. Then, at 7:05 p.m., 2 of the skywalks suddenly collapsed without warning. 114 people were killed and more than 200 were injured, making the incident the deadliest structural collapse in U.S. history until 9/11 happened 20 years later. Investigators found a small, last-minute change to the rods holding the 2 collapsed skywalks that meant that instead of each holding its own weight, they were linked together. Originally, rods went from the ceiling all the way through the fourth-floor skywalk and down to the second-floor one, with pieces underneath each skywalk supporting its immense weight. But after the change, the second-floor skywalk hung from the fourth-floor one. So supports for the fourth-floor skywalk weren't just holding up one 29-metric-ton skywalk, they were holding up 2 of them. It also didn't help that to save some money, the building materials themselves weren't quite as strong as they should have been, and on the night of the party, the extra weight of a couple dozen people standing on the skywalks proved to be too much. What seemed like a tiny change to their construction turned out to have terrible consequences. Manhattan's Citicorp Tower, which is now just called 601 Lexington Avenue, proves that projects with problems don't always end in disaster. The skyscraper's triangular top makes it stand out from afar, but you'd notice something else if you were just walking by. Citicorp Tower was built on stilts, which turned out to be a problem. The stilts were built to accommodate a church next door that essentially said they could build the skyscraper on the property as long as it didn't block the church. So the building's designers just decided to start most of the tower 9 stories up. They knew that such a tall building with so little on its bottom floors could be prone to toppling over in strong winds, so they wanted to make sure that it could withstand even the strongest winds blowing against its windows. So they added extra weight to the top of the tower that moved in the opposite direction of any lean the wind might cause. Wind against a skyscraper's corners usually just sort of slides past the building, so Citicorp Tower's designers didn't even bother checking for them. And that probably would have been fine if the stilts were on the corners. But because of that weird thing with the church, the building's stilts are in the middle of its sides. And in 1978, about a year after the center opened, a college engineering student figured out just how unstable the building was. Some calculations showed that storms strong enough to topple the tower hit Manhattan about every 16 years. It's pretty alarming. The building's designers didn't tell anyone other than the New York City Police Department and the Red Cross, who helped them secretly work out an evacuation plan while the building's internal structure was quietly but frantically improved every night after the office workers who were using the building went home. Braces that had been bolted together during construction were now welded to steel plates, making the connections between them stronger so Citicorp Center would be sturdier in the wind. In the end, everything turned out fine. The repairs were finished after just 3 months, and the only major northern hurricane of the year missed New York City. But almost no one knew about any of this until 1995, when someone finally spilled the beans on just how close New York came to having a skyscraper fall over in a powerful storm. London's Millennium Bridge was another project with a major design flaw that got fixed before it led to disaster. The bridge opened on June 10, 2000 as a way for pedestrians to cross the River Thames. It was touted as an engineering accomplishment at the time, a sleek new bridge to mark London's entry into the 21st century. Then, it promptly closed for repairs on June 12, 2000. And no, I did not say that wrong. It was open for a grand total of 3 days. The problem wasn't weight or wind or waves. The bridge was plenty strong enough to deal with everything it was supposed to hold. Instead, it was the people themselves who were unintentionally making the bridge sway back and forth like a pendulum. Some sort of random coincidence would get a wobble started, like a bunch of people randomly stepping on the bridge on the same side at the same time. And with up to 2,000 people crossing at once, that sort of coincidence was bound to happen sometimes. Then, once the wobble got started, it was easier for people to walk with that wobble than to fight against it. So many people walking in sync made the wobble get even bigger, and soon it got so extreme that people couldn't walk across the bridge without grabbing the side railings. The bridge probably wasn't in danger of failing because people would stop walking once the wobbles got too big and wait for them to die down before continuing. But the wobble would have still weakened the bridge over time, and the bridge's engineers knew what happened to Tacoma Narrows. They weren't taking any chances. So they decided to close the bridge pretty much immediately before the wobbles started causing other problems. They spent the next 2 years adding dampers all along the bridge, which absorbed most of the force from pedestrian steps to keep the bridge from swaying. The bridge reopened in 2002 with all the dampers firmly in place, and it's been a famous tourist attraction ever since. Designers and engineers are human, and occasionally they make a mistake that isn't caught, or there's a factor that no one anticipated. Sometimes, like with the Citicorp Tower and the Millennium Bridge, the issues are fixed in time. In other cases, they can lead to catastrophe. But generations of engineers have studied and learned from these failures, and there's no telling how many potential disasters have been avoided because of those lessons. Thanks for watching this episode of SciShow, which was brought to you by our patrons on Patreon. If you want to help support this show, you can go to patreon.com/SciShow, and don't forget to go to youtube.com/SciShow and subscribe.
Okay, that was a engineer nightmare. Every engineer want to avoid it because, yeah, everything that went wrong was pointed to you. Who are designing it? Who are making the work to done? Who give the stamp? Who give the signature? All of them must be point to responsible for the destruction. Okay, it was finished for the registration. How's the destruction? Is it bad? All engineers want to avoid it. But how? This is the way. An engineer must obey all the acts that are given to you. All the do things and don't do things must be obeyed. Okay, next I'm gonna share with you for the next subtopic, and also by using the Prezi application. So step. Okay, let's proceed with the second column, which is consultancy. Consultancy, also under the Registration of Engineers Act 1967, there is do's and don'ts do thing under the acts below the consultancy. Let's have a look. Do things. There is a few things that you have to consider. First is acceptable. Should accept peer review on their works. You as engineer should accept any review from your co-workers or any peer that review your works. This is really important to improve on what are you doing. You also can learn a new thing from the comment given. So you should accept all of the peer review. But if you don't like it, you can stand your reason. Next is about the open-minded. A checker must be open to critique and have an argument about the disagreement. If you are a checker, you must open to critique and you must have a good argument on what that you don't like. Okay, next is learn more. You, as an engineer, should learn new knowledge and skills. As you all know that nowadays, technologies was taking part. Every day, new technology was invented. You, as a new engineer, must learn from it. Take all the knowledge and sharpen your skills. This will help you to become a good engineer one day. We proceed with this fourth things, which is registered. Make sure the employee was registered with the BEM, Board of Engineer Malaysia. You as an engineer have to make sure all the employee registered with the BEM. This to make sure the quality of your works. Ethical. Report unethical practice to BEM. You, as a young engineer, have to report unethical practice such as bribing and not completing works. This is a huge thing when it comes to ethical. Now is responsibility. You must take a responsibility to a person that delegated with. If you are sending someone for doing your job, you have to take the responsibility on whatever the job being done, either it have a problem or not. It is the same thing if you are doing that job, so you have to take the responsibility. Okay, now is optimum use. Use optimum manpower, materials and money. As an economical engineer, you have to use and maximize all the sources that you got. This to make sure the less of loss for your company. Last but not least, local products. An engineer should aware of government requirement to use local materials. Malaysia produce a lot of materials for construction. It is important for you as a Malaysian citizen to use this local product. This also enhance the economic of Malaysia. That's what our government aware of. Okay, we are done on those things. Let's have a look on don't things. These are the things that you should avoid when you become an engineer. First, incompetence. Checker should not accept checking of their works out of their competence. A checker should not check something that out of their scope. This is not an ethical thing to do. Underpaid. Not carry project out of his payment. When a project is down from the payment, you should not accepting it because it will lower the rate of the jobs for the future. So it's not good for you as engineer to carry out the project. Next is endorse. Don't endorse any work that not supervised yet. If you are not supervised the job yet, please don't endorse it. It is your responsibility. Okay, let's proceed with the retakes. Don't supplant other engineer. If you got a tender or work, do not supplant other engineer. If you want to cut the cost, this is not the way. Safety. Do not compromise public safety. Always to make sure safety first. everything that related to public, you have to make sure you're not compromising. It is your responsibility. Opinion. Don't offer opinion if not sure with it. If you are having an opinion but you didn't do a research about it, please don't loud it out. BEM. Do not have any conflict that related to the work unless with approval of BEM and client. If you are not agree with the job, please do not have a conflict with it. At least you have the approval from the client. The last one is scope of work. Don't accept work outside of regular work unless get the express with the employee. You must create a good relation with your employee because they are gonna do your jobs. So please don't accept any job that out of their scopes. It will make harder for them to make it done. But if they willing to make the job, so you can accept it. Okay, that is the don't do thing. You feel tired, right? Listening all of the fact. Now it's snack time. Let's have a look with the metal industry accident. This will bright up your eyes. Please have a look.
Top 10 accidents in metal smelting.
Number 10.
Slag explosions. Slag or metal waste is the waste material after ore purification that will not be used in the metal processing. Though there has been a progress in recycling this waste material in the last years, a significant portion of it is still stored as dump in special containers placed in big holes on the ground. At least 24 hours are needed for slag to become solid and be disposed of. We must point out that after that time, waste is still red hot. A problem from this action could be when due to several factors. When metal impurities mix with water, for instance, a big explosion can occur. In addition, just a little amount of liquid is enough to start deflagration. Slag also brings other hazards to workers. They are less visible though. In some occasions, they emit toxic gases that could be lethal if workers do not have the proper protection.
Number 9.
Electric arc furnaces. The electric arc furnaces have been substituting traditional furnaces in many steel plants worldwide. The main reason for the substitution is their high effectiveness when producing metal from ore. For example, in more advanced workshops, these types of furnaces may produce up to 80 metric tons of liquid steel in just 60 minutes of functioning. To heat steel, an electric current going from one electrode to another is used. Despite the fact that these types of furnaces are considered much safer than the former ones, they are not free from risk. They must be cooled with water, and any little mistake when introducing the electrodes into them or any rest of the moisture on them could produce an explosion. This is what seems to happen in the video. When it is very hot, we can hear small explosions, and they continue to increase until a bigger explosion occurs. Another explanation for this explosion may be any mechanical human error when introducing electrodes that have been overheated or that generate sparks. In arc furnaces for cast steel, electrodes are put into on top of the tank, and it is not always easy to do it properly. On the other hand, accidents, like the one in this video, can occur. In this case, the problem may be caused by the amount of slag in the furnace. This material behaves similarly to volcanic lava. Flames are spread everywhere, and in the end, all content is spread all over the place.
Number 8.
Explosion in the boiler. Boilers are very important in the metal industry. They are defined as closed pressure vessel where a fluid is heated by applying the resulting heat externally. There are diverse types of boilers with different characteristics depending on their structure and way of functioning. In general, they are elements that involve several safety measures, but when they fail, serious accidents may occur. The most serious accidents can produce dangerous explosions. One of the main causes of these explosions is the low level of water that's needed to cool the boiler. The overheating of the structure causes deflagration and a subsequent disaster. All boilers must have at least 2 indicators for water levels. Accidents are normally produced by human error in the maintenance of this device. Another possible cause for accidents is the corrosion of the material they are built with, and of course, when water is mixed with the boiler content.
Number 7.
One of the hazards to be considered in the metal industry is fire. Fire increases the possibilities for accidents to occur. There are several causes for a fire to be started in these factories. The first cause to be considered is static electricity. This is originated by surface friction, and it can be accumulated until it begins to produce sparks that will start the fire. Another cause of these accidents is heat generation by machines. The flammable liquid and the liquids used for cooling these machines may be a cause for these accidents. We can also point out as causes of fire are the overheating of electricity conducting cables and the spontaneous combustion of chemical products produced by high temperatures that are usually common in these factories. Experts also emphasize the use of oils to lubricate or cool the machines. These oils are in many occasions the responsible for the start of fires. They also contribute with their fast spread and very dangerous toxic smokes.
Number 6.
Moisture. Water entry or just simple moisture in the boiler can produce very dangerous explosions that could put at risk the workers' integrity in the metal industry. Liquid steel can reach 1,500 degrees Celsius, and when water makes contact with it, everything put together can explode. It is important to know that water boils at 100 degrees Celsius. Therefore, when water is mixed with the metallic material, it starts to boil violently. It is important to bridge the gap, as when a drop of water falls onto boiling oil, but considering that water expands 1,700 times when it transforms into steam. This causes explosions in closed spaces. This effect can be seen perfectly in this video. The liquid has entered the boiler and it blows up violently. It is about accidents that often occur in autumn and winter where there is more moisture in the environment. Besides this, water can enter into the boiler accidentally by a break in it. Similarly, these accidents are likely to happen when the machine has not been preheated properly.
Number 5.
Dumping and slag. We cannot consider the slag dumping as an accident, but the consequences of this action can be very negative. Slag, or waste, originate from ore smelting to purify metals. It is about waste residues of this process, and it is a mixture of metallic oxides. In some occasions, it also contains metal sulfides. At present, slag storage and later treatment is assessed. Most of it can be reused for diverse commercial use, while another part is dumped in special areas. The problem arises when some industries located in countries that are disrespectful with the environment dump these wastes into the natural areas, or when by any accident they end up out of the dumping grounds, causing damage to soil and rivers as it happened in Hungary. On the other hand, according to ecologists, even though the slag is dumped in authorized areas, it always causes high pollution, reaching fields and water that are far away from the area it was dumped.
Number 4.
Steel casting ladle break. Broadly speaking, the steel casting ladle is a tool used in the metal refining and casting. It is used to transport and pour the red-hot metal. They are made of steel and have a refractory lining to withstand high temperatures. Lately, it has become a metallurgic reactor. This has obviously expanded not only their capacity, but increased the possibility for accidents to occur. As you see in this video, The workers driving the crane made a mistake that fortunately did not cause damage. Moreover, when pouring the metal cast, the ladle adjustment may fail and accidents may occur. This happened in Huachipato, where an explosion took place. To finish it, it is important to point out that sometimes there may be mechanic failures in the steel casting ladles due to poor maintenance in the fireproof lining. High temperatures of metals may damage the ladle when the cast metal is poured into it. In those events, workers are exposed to high risk as dangerous fires can suddenly be started.
Number 3.
Molten metal splashes. One of the most common risks in metal smelting are the splashes of molten metal. It is in fact one of the points for risk prevention. This is because of the relative frequency of an event like that. It also may bring very serious consequences for workers. As an example, iron and derivative alloys, such as steel, can reach a melting temperature of about 1,700 degrees Celsius. One of the causes often pointed out by the experts is the electrolytic reduction. This is a method to eliminate oxygen from metallic oxides through electrolysis. This method may originate small explosions. Obviously, a splash at that high of a temperature can cause serious injury. That's why the selection of fabric to make the protective suits is very important, as these suits could protect and save lives.
Number 2.
Eruptions in metal casting centers. The steel smelting activities are riskier than other industrial activities. One of the causes is, in fact, the high possibility for explosions to occur. A very risky event is the metal casting process. This process consists of pouring the smelted metal into a cast for it to become solid. One of the causes in this process for an explosion to occur is water in any component involved in the process. For instance, rest of water in the sand used to make temporary casts. Additionally, casts must be preheated to avoid any hazard. If there is liquid in any of the other pieces, this could also cause deflagration. There is a common saying known by the workers of the steel smelting activities. This saying warns, "Too hot to touch, it is wet."
Number 1.
Fire loops or cobble. In spite of its showiness, this kind of accident can be lethal for workers who are near. The temperature of this kind of molten metal loops is extremely high. These loops are capable of causing very serious injuries to anyone who is reached or touched by them. It could be said that these loops are sort of a spill of the smelted metal. This phenomenon happens when metal is heated and it is put onto rollers to change its shape and send it to a conveyor machine. As a result of a timing error in the process, the metal is ejected at a very high speed from its way in the rollers. It is necessary to take into account that these rollers leave less room among them the way the process is in progress. This is why they get this strange shape and fall forming, burning circles. We can see an example in this factory in Poland. We can see perfectly the moment when the metal is shot out from the rollers and forms a big ring of molten metal. Fortunately, there are not workers nearby when this happens, as there are no protective suits to resist the high temperature of these loops.
Okay, that's all consultancy. Thank you for watching. Now you all knows about the registration and the consultancy. Consultancy is all about the thing that you have done must be someone that check it. This is really important when doing your jobs because someone must check all your thing that you are making to avoid any unnecessary disaster happen. Alright, the last point is about the supervision. Let's proceed with the presentation. Hi, welcome back. Now we are proceed to the third column, which is the supervision. Supervision. Uniform Building by Law UBBL 5. This is the law under supervision. On supervision, it have three columns. which is do's, don'ts, and targets. We look at the first column, which is do's. Do's thing. First is responsible. Submitting engineer should responsible on the project that they conduct. If one day you become a person or an engineer that being submitted, you have to make sure that all project under your responsibility. This is because all the action that you take to conduct the project was really crucial, because all must be taken in precaution step. So, if you are chosen to become one of the submitting engineer, please make sure that you do your best. Now, we will proceed to the proper work. Have to precisely, proper and correct in approval of work. If you are doing a proposal, you have to make sure it is really proper and correct in order to get the approval. Therefore, you have to do a lot of homework about your work. We proceed to the third column, which is familiar. Must familiar and smart on the supervised work. This is because when you make a work and you keep repeating it, you will know and become familiar with all the problems that you have to face. So, you have to be smart on it. The next column was well trained. Make sure all staff have proper skill training. An engineer must make sure that their colleague have a proper skill before doing a site work. This is really important because in the site, we want to avoid injuries. So, please make sure all the staff have the skills and they get their training. Let's proceed with the safe documents. Make sure all documents needed was kept in safe place. If you be an engineer one day, you must make sure all documents that you have was kept in the safe place. This is important to protect you from become a victim. The last one is the knowledgeable. Must knowledgeable on handling the time and cost. An engineer must know how to handle time and cost very precisely. This was really important because time cannot be buy, and make sure that you cut the cost or use at least amount of cost to get a lot of profits. It was really important. Okay, that's it for the do's thing under the supervision, which is the law is uniform building by law. Okay, right now we proceed to the don'ts column under supervision. Don'ts. There is 6 columns under don'ts thing. The first one is overpower. Do not over or under certify progress of work. It was really important on doing your job. If the work was certified, you must make sure that you not over the power of the authorities in order to save your place on your work. If you become the one that control or over your own power, the authorities will find out and the chance of you survive for your works was decreased. So please make sure you not overpower. The next one was certificate. Don't make wrong certifications. First certification was really illegal. You are taking others' chance to get the job because you are making the first certification. You are not competent enough to become an engineer if you are faking your own certification. You must be honest to yourself in order to get a good job for you. First certification must be avoided in order to become an engineer. Next was verify. Don't verify work that out of expertise. If you are an engineer and you were asked to verify a work that out of your expertise, please do not sign the works, or please do not sign the proposal. As you can see on the picture below, it was a disaster at the Chernobyl that located at Russia or Soviet Union. The disaster was really bad because it related to the nuclear power station. The core was exploded and spread all the radiation to humans and made them feel sick and got cancer for a long time. This disaster shows how unexpertise workers are used to run the nuclear reactor. The next was unqualified. Do not accept staff that not qualified enough. If you become a boss one day, please make sure all your staff was qualified. If you need someone in low level of education like SPM or higher education level like diploma or bachelors, make sure they were qualified enough to take the job. Okay, the fifth column is justification. Don't delay approval without justification. If something that needs your approval for them to do their jobs, please do not delay it without any justification. If you delay the approval, it will make them hard to do their works, and the progress of the works will become slow. So if you have something that need to delay the approval, please give the justification. The last one is delay. Please do not delay inspection of work without any strong reason. If you are someone that need to do an inspection of the work, do not delay it because every inspection have its timeline. If you delay, you are taking others' time for their own inspection. So please respect your time and others. Okay, that's it for the don't do things under the supervision. Okay, right now we have the last column, which is targets. Let's have a look.
Ever looked up at a skyscraper and wondered who built this? An architect? An engineer? A builder? Well, yeah, all of these people play a role in designing and constructing a building. A project like this needs a team of hundreds of people, and like any great team, they need a leader. In fact, a project this huge needs a whole team of leaders. Let me introduce you to a few of them. Let's say a property developer has already selected the site and decided that it's ideal for a brand spanking new skyscraper.
Yeah.
Where do we start? Call in the bulldozers and start preparing the site? Pour the concrete? Hold on, this is a huge project. We need to do a little planning first. So we've appointed Kim as Senior Project Manager, the leader of our team of leaders. Kim's got years of experience in this game. She'll map out the whole process from start to finish. Who else? Well, there's Max, our design manager, who works with the architect and the engineer to design the perfect building. It's got to be beautiful, it's got to be functional, it's got to be really, really tall, and it's got to stay up. Max is pretty important. Without him on board, we could end up with a really dodgy building. Max gives the plans to Jamie, our quantity surveyor. He figures out how much it's all going to cost. It takes a huge pile of cash to build something on this scale. But without Jamie keeping an eye on the bottom line,
How you doing?
it could take a massive pile of cash. Jamie works closely with Steve, the construction scheduler.
Hi.
Steve's job is to figure out how long everything's going to take. Like, if it takes 10 workers 2.5 years to build a 20-storey building, how long will it take 50 workers to build a 120-storey building? Never mind. Let's just say that without Steve it will take a really, really long time. What next? Don't we need some cranes and bulldozers? How about a plumber, painter and an electrician? We sure do. That's why Amy, our contract manager, is organising all the contractors, the people who do all the hands-on stuff.
Hi.
Without Amy, well, not much would happen at all. Now we're ready to get started. Bring on the bulldozers, pour the concrete and lay the footings. Up go the columns, in go the slabs, on goes the cladding, and that's pretty much it. We just need to connect the utilities, paint a few walls, tile some floors, and voila. One skyscraper delivered right on schedule. That last bit can take quite a while, anywhere between a few months and 2 years actually. But don't worry, Kim was keeping an eye on things the whole time, making sure everyone did their job safely. Without her, who knows where we could have ended up. What do you think? Want to join this exciting team? Perhaps you're cut out for a career in construction management. But what do Kim, Max, Jamie, Amy and Steve love best about their jobs? At the end of the day, they get to say, I built this.
How did that get? It was nice, right? To become an engineer one day, you can build a skyscrapers. So you can story all details to your son or grandson. So an engineer was a good job because it have a lot of their own difficulties. In order to overcome the difficult time, you have to make sure that you do all the best because it is for your future. That's it from the supervision. Hi, if you managed to watch the video until this scene, you have completed 3 subtopics under do's and don'ts of engineering. Currently, you have the knowledge about the registration, the consultancy and supervision. Right now, I want to show you the conclusion of my topics, which is these 3 subtopics. So at the end of this video, students are able to know 3 basic things on do's and don'ts of engineering. First is under registration. If you are a young engineer that have graduated in any field of engineering, like I said before, you have to register yourself in the Board of Engineering Malaysia. In Malaysia, we call this as Jabatan Jurutera Malaysia. In many institutions in Malaysia, once you have graduated bachelor's degree of engineering for any fields, automatically registered on Board of Engineering. So you don't have to do yourself because your institution have done it for you. It was really helpful because it made you easier to be listed out at the Board of Engineering. Okay, right now the second subtopic is talking about the consultancy. In this subtopic, we are talking about the taker. If you've done a proposal for any works, even the jobs that you have to be done by you, you have someone that check your proposal. It was really important to avoid any injuries. Yeah, every person do have a problem in anything. No one perfect. By understanding the act of consultancy, you must know that the checker was really important in order to make sure you complete your job without any accident. From now on, please make sure that you are obeying this kind of rule. So, the last point was supervision. Make sure all aspects under the job must be considered, such as experiences, knowledge, skill, and registered. It means once you are doing your jobs as a young engineer, you have to make sure that all staff that working with you have their own certification. You have to make sure that they got their skills on managing any problems. It was really important for you to make sure all these things being done by a person because you are working with them in order to make sure your job was done. If you're working with someone that not competent enough, it may not work out with you because just imagine this. You were assigned to design a circuit or design a machine that need electrician and programmer. You need someone that knows about the connection of wire. You need someone that design the drawing of the boards of the circuit. You need someone that design the whole machines. What if all the person in charge was not competent? It may was up your works. You as a young engineer must be responsibility on any task that you given to them. To make sure the machine was running, it must have someone that competent to do their jobs well. This is one of the example that I can give to you. So, after finish all three subtopics that I give to you, you have already known this thing. So, I hope you enjoyed it. Alhamdulillah, we have finished our three subtopic under do's and don'ts of engineer. There is another two, but I'm not gonna say about it because my friend Nashin has about it. From now, I hope that I give you a lot or less information about an engineer. All the things must be obeyed in order to avoid any unnecessary thing to happen. That's all from me. Thank you for watching my video. Hope you like this video. To see you again.
Hello, Nasrin here. So, in the previous slide, Ajim has explained to you about the do's and don'ts of registration, consultancy, and supervision in the Registration of Engineers Act 1967. Let's take a look to the next slide of regulatory requirements for Act 138.
All engineers registered with the Board of Engineers Malaysia (BEM) must be familiar with the requirements of the Registration of Engineers Act 1967, Act 138, and its subsequent amendments.
You know, ignorance of the requirements for this act is no defense in the courts of law in Malaysia. Let's take a look for the do's in the regulatory requirements.
First, an engineer should notify the relevant authorities within reasonable on changes in design or withdrawal of services. Second, an engineer should submit completed forms in time for inspection and approval for Certificate of Fitness or Certificate of Completion and Compliance. Next, an engineer should be aware of environmental, health, and safety matters during and after construction. Lastly, an engineer should ensure that environmental, health, and safety measures are implemented as per drawings and specifications.
How about the don'ts?
An engineer should not allow works to proceed before plans are submitted or approved by the relevant authorities. An engineer should not undertake a project for which the client is not going to fulfill the requirements.
What happened if none of these were not implemented by engineers? It's all about safety. Let's watch a video of these construction failures that were attributed by engineers.
A collapsing bridge is a terrifying thought for many. Here are 10 bridge failures explained. Number 10. The Harbor Taiwan Bridge Collapse of 2019. This relatively new bridge in the Yilong County of Taiwan experienced an epic fail when it collapsed in October 2019. The bridge's collapse was caught on camera. The bridge, which was a 459-foot single-arch bridge, was built in 1998. But on October 1st, 2019, the bridge gave way, sending a petrol tanker into the water below. The total death count caused by this collapse is unclear, as some missing people have not yet been found, but there have been at least 6 confirmed deaths. The cause of the collapse is still being investigated, but the collapse was likely caused by heavy rains coupled with high winds. Number 9. The I-40 Bridge Collapse of 2002. On May 26, 2002, the I-40 bridge experienced a massive collapse. The bridge, which was located in Webbers Falls, Oklahoma, fell into the Arkansas River at the Robert S. Kerr Reservoir. This caused 8 passenger vehicles and 3 semi-trailers to also fall into the river. Nearby fishermen were quick to respond, and they helped to pull people from the river. But even with rescue efforts, 14 people lost their lives in the collapse, and another 11 were injured. The collapse was caused by Joe Deadman, who was the captain of a towboat. Suffering from abnormal heart rhythms, Deadman lost consciousness and thus lost control of the barges he was towing. The barges collided with the bridge pier, causing the 580-foot bridge to collapse. It took 2 months to rebuild the bridge. Number 8. The Majorhat Bridge Collapse of 2018. The Majorhat Bridge in Kolkata, India, had been under scrutiny for some time before it finally collapsed on September 4, 2018. The bridge was 50 years old and beginning to show signs of wear and tear. Commuters and local police were concerned by the cracks in the bridge, and an audit in 2016 warned that the bridge was unsafe. Furthermore, the bridge did not receive the proper road maintenance that it required. So it was not surprising that the bridge finally gave way. The collapse injured 25 people, and 3 people died in the collapse. The collapse was preventable if the proper measures had been taken. Before we move on, be sure to subscribe to Daily Top 10s with notifications on so you don't miss any of our videos. Number 7. The California-Nevada Bridge Collapse of 2018. When a section of the Interstate 10 in Southern California collapsed, it brought catastrophic consequences. The collapse involved a section that was only 30 feet long, but the collapse severed off transit between Southern California and Arizona. The very busy road is the quickest way to get from Phoenix to Southern California. With the road closed, thousands of people were forced to detour hundreds of miles to alternate routes. Reports indicate that the failure was caused by floodwaters and that the bridge's structure had been compromised. Number 6. The Interstate Minneapolis Bridge of 2007. The 35W Bridge was once an 8-lane bridge that crossed the Mississippi River in Minneapolis, Minnesota. The bridge opened in 1967 and quickly became one of the busiest bridges in Minnesota, carrying upwards of 140,000 passenger vehicles per day. But on August 1, 2007, the bridge suffered a catastrophic failure. The failure occurred during rush hour and resulted in the death of 13 people. Another 145 people were severely injured during the failure. The failure was the fault of a design flaw. One of the gusset plates was too thin, causing it to rip through a line of rivets. The bridge was reconstructed after the failure, but did not reopen until September 18, 2008. Number 5. The Kantho Bridge Collapse of 2007. On Wednesday, September 26, 2007, a catastrophic bridge collapse resulted in a very high death toll. The bridge, which was 300 feet long and 98 feet above the ground, came crashing down onto an island in southern Vietnam. The collapse has been called the most catastrophic disaster in the history of Vietnam's construction industry. The collapse killed 59 people and further injured another 140. At the time of the collapse, there were 250 engineers working on the bridge. The collapse was horrific, and people who witnessed it said it sounded like a huge explosion when it collapsed. The collapse was caused by human error. Heavy rains had softened the foundations of the pillars that held up the bridge. Construction workers had moved temporary pillars before the permanent ones, poured only 2 days prior, were stable enough to hold the weight of the bridge. These two things combined caused the bridge to collapse. Number 4. The Seongsu Bridge Collapse of 1994. The Seongsu Bridge is located in Seoul, South Korea. On October 21, 1994, the bridge suffered one of the worst collapses in recorded history. The collapse was due to a structural defect. The steel trusses that were part of the suspension structure underneath the roadway were not welded properly. When they came undone, they caused a massive section of concrete to fall into the water below. 17 people were injured in the bridge's failure, and 32 people were killed. The bridge was scheduled to be repaired shortly afterwards, but the structural deficiencies were so severe that the entire bridge had to be redesigned. The new bridge opened on August 15, 1997, and although it looks similar to the original bridge, it is far more stable and structurally sound. Number 3. The Miami Pedestrian Bridge Collapse of 2018. When engineers noticed that the cables holding up a suspended pedestrian bridge in Miami were loose, they ordered that the cables be tightened. But the order came a little too late. While workers were tightening the cables on March 15, 2018, the suspended bridge collapsed, crushing everything beneath it. The bridge was built between the FIU and the community of Sweetwater as a safe way for pedestrians to cross the busy 6-lane Route 44 highway. The bridge cost $14.2 million and was undergoing stress tests when it collapsed. The bridge, which weighed 950 tons, fell onto vehicles that were stopped at a red light. 6 people were killed, and another 10 were seriously injured. The bridge was innovative and unique in its design, namely for its innovative installation. But because the bridge was so innovative, designers had little experience with the actual application of the design. Furthermore, construction of the bridge had been accelerated to minimize disruption to traffic. So its innovative design and its speedy construction made it a risky endeavor. It's unclear exactly what caused the bridge to collapse, but it was likely a design flaw. Number 2. The Tacoma Narrows Bridge Collapse of 1940. The collapse of the Tacoma Narrows Bridge on November 7, 1940 was a pivotal bridge failure in terms of bridge engineering. The bridge collapsed only 4 months after it had opened, and the collapse was due to aeroelastic flutter. The aeroelastic flutter was caused by winds that ripped through the bridge at 42 miles per hour. The bridge had been nicknamed Galloping Gertie because it wobbled in the wind. The bridge was not designed properly to withstand the notorious winds in that area. The bridge was built with solid walls that did not allow wind to pass through it. Thus, wind became trapped within the walls of the bridge, causing it to wobble in the wind. During a particularly harsh windstorm, the bridge was no longer able to withstand the wobble, and the bridge gave way, causing it to plunge into the Puget Sound below. The collapse of the bridge changed bridge engineering in the decades that followed. Engineers were able to learn from their mistakes and to create better and stronger bridges that did not have the same flaws as the Tacoma Narrows Bridge. Number 1. The Pont de Barcas Bridge Collapse of 1809. Often called the worst bridge disaster in recorded history, the collapse of the Pont de Barcas Bridge is one of the most catastrophic bridge failures that the world has ever seen. The unique bridge translates into the Bridge of Boats, as it was made from boats and planks. Huge wooden planks were put over the top of boats that floated in the water. The bridge was supposed to be secure this way, as it could rise and fall with the ebb and flow of the river. But during a panic, too many people boarded the boat bridge and it collapsed. The collapse happened during the Napoleonic War. On March 29, 1809, French troops were advancing into Portugal. Thousands of French troops marched into the city of Porto, and the people of Porto tried to escape the advancing French troop by flocking to the nearby bridge. The bridge crossed the Douro River, and people flooded onto the bridge to find safety on the other side in Gaia. However, the bridge was not able to withstand the weight of the people on it, and the bridge collapsed into the river below. The actual number of people who died during the collapse is uncertain, but reports of the event put the final death count between 4,000 and 6,000 people. When the bridge collapsed, people fell into the torrent river, and, unable to swim to shore, they drowned. It was a tragic bridge failure, with unparalleled consequences for the people of Portugal, which is why the Pont de Barcas bridge collapse has earned the top spot on this list of 10 bridge failures explained.
What can you conclude from the video? From the video, we can see that some of the accident is due to human error. If these engineers prioritize the safety concern, the bridge might be as strong as the Golden Gate Bridge in San Francisco in California, which it is built in 1933, and the structure is strong until now. Next, let's move to the Code of Ethics. All the engineers are expected to uphold the integrity of the profession by behaving in a manner. The word ethics originates from the Greek word ethos, meaning character. So, what are the good ethical behaviors should engineer have? Do's in the Code of Ethics. First, an engineer must be familiar with the Code of Conduct of Engineers. Second, an engineer must understand the need of responsibility and liability as specified in the Code of Conduct. Next, an engineer must respond promptly to complaints and inquiries by clients or any other authorities. Things engineers should avoid in Code of Ethics.
An engineer should not solicit or tout. Secondly, an engineer should not knowingly mislead the public by giving misrepresented information so as to gain commercial advantage or mileage. Next, an engineer should not respond to an open advertisement to bid for provision or professional service if such provision for the service requires bidding fees or equivalent as is usually imposed on contractors. Lastly, an engineer should avoid favoritism among vendors and other suppliers.
Good ethical will make us become a good engineer. Let's watch this video about the good ethics.
Not in a million years. Wait a minute, how much? Actually, I might consider it. Hold on a second, Mel. I got a client coming in. No, I'm going to put you on hold. Hold on. Hello, how are you? Smiley face. Whoa. Calm down. There's no need for that kind of language. What seems to be the problem? Of course I'm aware our product doesn't have a flammable warning. I sell them. Grilling, you say? I am so sorry. What was his name? Sparky? You gotta be kidding me. I'm afraid I can't really do anything about it. I know I'm the one who sells the products, but I'm not the one responsible for safety clearance. That's our manufacturing division. Take it from me, they're a bunch of clowns. If it was up to me, we would restaff the entire division. But management isn't really interested in spending more money after the other flubs they had this year. You wouldn't believe the amount of customer complaints we've been getting. R&D, legal, management. We're talking incompetence across the board. Except sales, we're cool. Smiley face, exclamation point. I know I should look for another job, but it's a tough economy. If I were you, I'd just avoid our products altogether until you hear about us being under new management. Thanks. You too. Stay fly. Melman, you still there? Mel! Yes, sir. Well, we'll follow through with that. Thank you very much. All right. Bye-bye.
Hey, Aaron, are you busy?
Well, the phone's been ringing off the hook all day, but what's up?
Well, I don't know if you'd heard, but one of our new products is out of spec.
Really?
Unfortunately, yes. Now, we're not laying the blame on anyone specific. I just thought that you should know because you're probably going to be getting some complaints from purchasers in the near future.
Well, thanks for the heads up.
No problem. Now, if you do get any calls, just make sure that you exercise responsible business communication skills.
I will. I will listen to the complaints, I'll file them properly, and I won't say anything that would be harmful to our business or the stakeholders.
Excellent. How we communicate with our customers is very important.
Yeah, I know. You know, in a case like this with a out-of-spec product, anything I say when dealing with a customer could be brought up in court. It's essential to maintain responsible, professional exchange.
You got it. Thanks, Aaron.
Thank you.
So all that little stuff like tie downs and connectors, just go with the count on the invoice. They're almost never wrong.
What about these wireless cards?
Count them. Is that the new 600?
Yeah, looks like it. There should be 25 of them here.
Cool. Let me see one. Just put down 24. What else is in there?
There's some flash drives and sound cards. Is that okay? Aren't they gonna miss that?
Don't worry about it. Just change it to 24. Look, this is what, your third day here? Tell me this. How am I supposed to recommend a product I've never even used?
Well, I don't know.
Of course you don't, because it's not possible. But if I take this home, start using it, then I can honestly tell our customers this is the best wireless card we have to offer. Get it?
Well,
What's up, guys? Hey, how's the newbie doing?
Not so good. We were just going over our little product testing plan, and he doesn't seem to be grasping the concept.
What's the grasp, kid? Getting free stuff is one of the main reasons I still work here.
But doesn't it seem like stealing to you guys?
Oh, stealing? From who? If you change it to 24, the store gets a free replacement. The distributor charges it back to the manufacturer.
And the manufacturer comes out ahead because when we tell customers we use these things at home, they sell more. Everybody wins.
I guess I never really thought of it that way.
Trust me. I've been doing this a long time. Just change it to 24.
Okay. So, it is my third day on the job, and I don't know all the company's policies yet, but a product testing plan that requires us to change the invoice? This sounds like a moment of truth to me.
Always remember, a good behavior, how you treat others and take responsibility is a reflection of yourself. We are entrusted by the public to provide safe transportation, safe structures to work and to live in, and the protection to the environment. So, the community is our concern as an engineer. Thank you for watching this video. I hope you finally understand the code of ethics for young engineers. Have a good day. Bye!